Okay, so far in this unit, we've been dealing with right triangles. And for right triangles, you can use Pythagorean theorem or SOHCAHTOA to solve for missing sides or missing angles. Now, what happens when you don't have a right triangle? Okay, and this is called an oblique triangle. How do we calculate sides and angles? Well, one type of way we can do that is by using the sine law. Now, before we get into the sine law, it's important to know how to label a triangle in oblique triangles. Okay, so your vertices are capital letters, A, B, C in this case, and then the lowercase letters are going to represent your sides. Okay, but the sides have to match the opposite angle. So across from vertex A, okay, right over here opposite it is going to be little a, and that's going to be side length A. Across from vertex B is going to be little b, that's side B. And across from vertex C is going to be little c, and that's going to represent side C. And this is important just to understand the formula, okay? Every vertex corresponds to its opposite side, and those letters have to match, okay? Your sine formula, okay, is sine A over A equals sine B over B. Or you can flip the fraction, A over sine A equals B over sine B. The letters can be anything as long as they match. It could be sine R over R equals sine S over S. It doesn't matter. Okay, I tend to use one formula. I don't mix it up. I usually use this one. It really doesn't matter which one you use. In order to use the sine law, you need to have a full match, a full pair. So I need to have a vertex and its opposite side. Okay, and then I also need some other information, another angle or another side. So I'm going to make a little note of that. Need a full pair or a full match plus another side or angle. Okay, that way you can solve for the other side or angle that matches it. Okay, so let's try this out. Okay, I'm going to start off by labeling. Angle B goes with little b, angle A goes with little a across from it, angle C goes with little c directly opposite it. Okay, do I have a full pair? Yes, my full pair is the A's. And then I'm looking for side B, and luckily I have angle B to match it. Okay, that way I have three known dimensions and one unknown. So I'm dealing with the A's and the B's, so my formula that I'm going to use is sine A over A equals sine B over B. And now I plug in what I have. Angle A is 58, side A is 6, angle B is 75, side B is B. That's what I'm looking for. And now, whenever you have two fractions that equal to each other, your first instinct should be to cross multiply. So I'm multiplying the B by sine 58, and that's going to equal 6 times sine 75. Now I don't go to my calculator just yet. Okay, I'm trying to isolate for B. What's in my way? The sine 58. So I need to get rid of it. And how do I get rid of it? By dividing it out. So I'm going to divide both sides by sine 58. That way, on the left, the sine 58 cancels out. And what you're actually going to be plugging into your calculator is B is equal to 6 times sine 75 divided by sine 58. Okay, so I use sine law because I had this full pair for the A's. Okay, now in your calculator, you have to be careful with brackets here. So if you have a nice calculator where you can set up a fraction, use it. Otherwise, you're going to be typing in 6 times sine 75, close a bracket around your angle, divided by sine 58. I want everyone to try this to make sure you're using your calculator properly. Okay, and what you should get is roughly 6.8 for B. Okay, if you didn't get that, maybe you can do it in 2 steps. Multiply 6 by sine 75, press enter, and then take that answer with you and just hit divided by sine 58, and you should get that 6.8. Okay, but that's it for sine law. It's just plugging values in to your full pair and your not full pair, and then cross multiplying. Okay, let's try another one. So I'm going to start off by labeling. Across from an angle K is little k, which is already labeled for us because that's what we're looking for. Across from angle L is little l, okay, but that's not given to us. And across from angle J is little j. Now looking here, my k's don't have a full pair, my l's don't have a full pair, or my j's don't have a full pair. However, I am given two angles, which means I can do a little quick calculation to figure out what angle j is equal to. So I'm going to do 180 minus 85 minus 50, okay, and that's going to give me 45 degrees. So that's what my angle j is. And now when I write it in here, I have a full pair between my j's. Okay, so here and here is a full pair, and I'm looking for side k, and I have angle k, so there it is, a full pair and the pair that's missing a little bit of information. So I'm going to write sine j over j equals sine k over k. So now I'm just going to replace everything. So sine 45 over 6 equals sine 85 over k. And once again, we cross multiply. So the k gets multiplied by sine 45, and that's going to equal our other cross, which is 6 times sine 85. Again, don't go to your calculator yet because I don't want you to lose a lot of decimals. So we're going to divide out that sine 45 because it's in our way, and we're trying to isolate for k. So k is going to equal 6 times sine 85 divided by sine 45. Okay, and that's what you're going to plug into your calculator. I want you to take out your calculator and actually try plugging it in to make sure you're doing it properly. So 6 times sine 85, close your bracket, divided by sine 45. And you should get approximately 8.5 if you round properly, because it's 8.45. So round it up, 8.5. Okay, that's solving the sides, which involves a little less work than solving for an angle, but we're going to try solving for an angle in this example. Again, step 1, label everything. Across from angle A is little a. Across from angle B is little b. Across from angle C is little c. And I notice right now my C has no information. That's going to be useless to me. But what I am looking for is angle C, and I have side C, and then I have a full pair between my angle B and side B. So I'm going to be using sine A over A equals sine B over B. I don't know angle A, but I know side A is 6. Angle B is 75, and side B is 7. And now I cross multiply. So I'm going to multiply the 7 by sine A, and I'm going to multiply the 6 by sine 75. Now, please, please, please pay attention here. I need to figure out this angle A, but angle A is attached to sine. So what I'm going to be isolating for right now is sine A as a whole. And if we remember from SOHCAHTOA, to solve for an angle, you're going to take the sine inverse. So I just need to isolate right now for sine A, and then I'll figure out the angle later, which means the 7 is in my way, so I'm going to divide both sides by 7. So sine A is equal to 6 sine 75 divided by 7. And once I'm here, I'm just going to take the sine inverse of that fraction to get angle A. Now personally, I like to do this all in one step. I like to write A is equal to sine inverse of my fraction, and I like to plug this into my calculator all at once. If your calculator has that capability, please do it. So we're going to try it together right now. If this doesn't work for you, I'm going to show you an alternate method, but this is the best one just because it keeps your accuracy. So you're going to hit the shift button, then sine, which opens up a bracket, and then you're going to hit 6 sine 75, close the bracket till your angle, divided by 7. And you should get approximately 56 degrees. If you have a calculator that has that fraction button, use it for that 6 sine 75 over 7. Otherwise, you can use division. If you didn't get this answer, here's a way around it. Okay, to find angle A, we're going to take the sine inverse of the decimal that represents that fraction. So in your calculator, you can type in sine or 6 sine 75 divided by 7, and you get 0.8279. Try to use as many decimals as possible, or just use the answer button next. So I take shift sign, and then I hit my answer key, which carries all of the decimals with me, and then press enter to get 56. If your calculator doesn't have that function, just write out as many decimals as you can before you take the sine inverse, like at least 4, just to keep the accuracy. Okay, and then you'd get 56 degrees as well. Okay, so if you have issues with this or anything with your calculator, please see me tomorrow so we can figure that out, or ask a friend, because it'd be really unfortunate if you could do the whole hard part of setting up your equation, cross multiplying, isolating for what you need, but then you mess it up because of your calculator. Also, just a reminder, make sure you're in degree mode on your calculator, because it would also be really unfortunate if all of your answers are wrong because you're in radians. Okay, on this page you're going to try a few examples and then check in with me after. So I want you to try number 4 right now. Label your triangle properly, figure out where your full pair is, okay, and then solve for angle P. When you finish that, check your work with me before you go on to number 5. Alright, so hopefully you got 36 degrees for angle P. If not, here's what you should have done. Okay, I saw that my R's were a full pair, the 45 degrees with the 12, and then I was looking for angle P, and it gave me side P, so I used R and P for my sine law. Okay, so this is my general equation. I plugged in 10 for P, 45 for angle R, and 12 for little r, and then I cross-multiplied. When I cross-multiplied, the 12 was multiplied by sine P, and the 10 was multiplied by sine 45. Now I need to isolate for sine P, so I divided out the 12, and then I knew I was going to take the sine inverse of this fraction. Okay, so these disappeared to get sine P, and then I took the sine inverse of that. So I did skip a step just because I was running out of space, but angle P should have been 36 degrees when rounded to the nearest whole number. Okay, if you made a mistake, see where it was. Did you plug numbers in incorrectly? Did you cross multiply incorrectly? What was the problem? Or was it just a calculator issue? Okay, so right now in our next triangle ABC, I want you to solve for side C. Okay, try it on your own and pause the video, and then come back and check your answer with me. Alright, so in this example, you had a full pair between B, and then we were looking for side C. And thankfully we were given that angle C. We didn't have to do a modification or a little calculation to solve for it. So this was the general formula I used, using the B's and the C's, and plugged everything in. When I cross-multiplied, the C was multiplied with sine 65, and the 7 was multiplied by sine 45. And when I got to this step, I had to isolate for C, which meant I had to divide out the sine 65. So this is what I was plugging into my calculator, and I got approximately 5.5 for side C. Okay? Okay. Pause the video again. I want you to try number 6. Label everything. If you messed up in number 4 when you were solving for an angle, okay, really try to fix that mistake in this example, and hopefully you don't make it again. Okay, so pause the video, try it out, and then check your answer with me. Alright, so hopefully you got 57 degrees for angle B, but you had a full pair for C's, and then we were looking for B. So this is the general sine law I used. I plugged everything and cross-multiplied. So the 4 with sine B, the 5 with sine 42. And in this case, because I was looking for an angle, I had to isolate for sine B, which meant dividing out the 4 from both sides. And then once I got this fraction and had sine B on its very own, I could take the sine inverse of it, and I got 57 degrees. Okay, so hopefully that kind of clarifies the sine law, and hopefully you got better at using your calculator to solve properly and keep it as accurate as possible.